last rule. What if I have a quotient, remember that's a division problem, to a power? Let's see what that could look like. Here's some examples. Okay, so what if I have something like this? 3x over n to the fourth, that's a quotient. And what if that is all to the fourth power? What would I do with that? Okay, well, let's actually just go ahead and write it out for this first one so we can really see it. This equals 3x over n to the fourth 4 times. Oh, sorry. Okay, so let's see what happens. Across the top, right? When we multiply fractions, we multiply across the top. 3 times 3. Okay, that's 9 times 3. That's 27. Times 3, that's 81. So this becomes 81. X times x times x times x. X to the fourth. Over. How many n's is this? This is 4 n's, another 4 n's, another 4 n's, another 4 n's. That's n times 4. That's 4 times 4. That's n to the 16th. Okay, so here's what I get. So we can observe. Okay, the number, like that number 3, we applied the exponent. This is 3 to the fourth power, right? This is 3 times 3 times 3 times 3. Okay, now what do we do with the exponents? Well, this was x to the first times 4. 4 times 4. So we multiplied the exponents. So what I want you to see is that this is very much just like a product to a power, right? We have the same observations. We apply the exponent to the number and we multiply the exponents, so it's the same. We just got to keep, the top and the bottom kind of separate here. Okay, now where it just gets a little bit tricky, where there's kind of like another step thrown in, is when you have something like this. Okay, now here's what you need to know about this. Simplify inside the parentheses first. Okay, now look, you could actually do all the work. You could apply the exponent here and then apply the exponent here and then simplify, but like it's so much more work, because if you simplify first, then you end up taking this exponent and applying it to something simpler. So watch what I'm going to do. I'm going to take this fraction, I'm going to keep the third power on it, but I'm going to simplify it. So like here, for example, this is 4 divided by 2, that's 2. This is 2 x's and 1 x, so like if I imagine this is x and x, I'm going to cancel 1. There's 1 x left over on top. This y, I have 1 y on the top and 3 on the bottom, so 1 cancels and I'm left with y squared on the bottom. So now when I go to apply this third power, now, and you could write it out the long way, right? Like I could do this. I could do 2x over right? I could do this. Okay, that's 2 times 2 times 2, that's 8. X cubed over 1, 2, 3, 4, 5. Oh, sorry, I wrote an extra y here. 1, 2, 3, 4, 5, 6. Okay, now for the second step, I also could have used the shortcut, right? I could have done 2 to the third. I could have done this as x to the first to the third power. And then 2 times 3 is 6. Okay, but there's my answer either way. All right, and then the only other sort of tricky complication you might see is this. What if this whole thing was to the negative second power? What do I do? This means you just take that whole junk and you flip it over. Okay, so watch what happens. I'm going to take this y to the third from the bottom. I'm going to put it on top. I'm going to take this 2x squared. I'm going to put it on the bottom. And I'm going to change that exponent to positive. Okay, we know that that negative exponent means things are flipping to the other side of the fraction. So I just took this whole thing and flipped it over. And now I'm going to do this. I'm going to say, oh, 3 times 2. Right? This is 2 to the second power is 4. This is 2 times 2, x to the fourth. Okay, so this looks like this. So if there's a negative exponent, on the outside, like this. Like if there's a negative here, like let's say this is a -3, flip it first. Okay, let's try some. Try some before you get to it in edge elastic. Okay, so here's this one. Okay, remember when you get to ones like this, you're going to simplify first before you apply this outside exponent, right? So simplify first, then deal with that second power. And then finally, try this one. With this, there's going to be a negative exponent on the outside. So remember what we do, we're going to flip that one over first. Okay, go ahead and try those.